Welcome. In this video, we are going to discuss isotopes and the importance behind isotopes. First, let's look into what is the definition of isotopes. We can see that isotopes are atoms of the same element that have the same number of protons but different number of neutrons. What do we mean by that? So, for example, we have carbon-12. We also have carbon-13. We also have carbon-14. Now, what is the similarities between all these three atoms? It's that they all have the same number of, that's right, protons. So what is different? Well, it's actually the neutrons. They don't have the same number of neutrons, but they do have all the same number of protons. And that's what makes isotopes. Isotopes actually considers that all atoms do not have the same number of protons. They do not have the same number of neutrons. Now, let's also look into something that's quite interesting. When we look into periodic table, we see that the atomic mass of carbon is 12.011, and for nitrogen it's 14.007, and then we also see aluminium is 26.982, silicon we have another one. And have you realized something, that these are not whole numbers? And what is the reason behind that? It's because these numbers are actually determined from the isotopes of this atom. So, for example, carbon, as I have shown, it has three isotopes: carbon-12, carbon-13, and carbon-14. So, this 12.011 is actually determined from all these three isotopes. Now, we are going to look, why is that important? Let me remove this and let's consider, okay? We are going to find the average mass of school children, okay? So let's say this is my school. It's rated on solar school. And here we have two grades. Grade 1, let's say it's 2 floors. And here we have grade 2. Now, the average weight of grade 1 students is 40 kilograms, and the average weight of grade 2 is 45 kilograms. Now, if I ask you to find the average weight of the school children, what we would do is actually we would 40 plus 45 divided by 2, because we are dividing between two grades. But that is only possible when we say that, okay, the number of students in grade 1 and the number of students in grade 2 is same, okay? So if we say that we have 50 kids here and 50 kids here, then of course we can do that. But that's not the case here, okay? Let's assume that we have 80 kids here, and we have 20 kids here. Now we have to take into account of this different number of students, right? Because it's not 50-50, it's not divided equally. So when we want to find the mass, what we are going to do is actually, we are going to do 40 into 80% plus 45 into 20% divided by the total percent. Say it's 100. So if we do that, we should find 40. Okay. We find out that we find out that the mass is actually 41 kilogram. Okay. So what does this mean? This means that our mass or our weight of the school is actually more close to grade 1. And what is the reason behind that? The reason is because we have more grade 1 kids. Similarly, the similar concept and logic is used for isotopes. So let's start with carbon. That's the most common one. So for carbon, as I said, you have C12, you have C13, and you also have C14. Now, what they found out okay, the relative abundance of C12 is 98.8%. For C13, it's 1.11%. C14, which is the least amount of relative amount of 0.01. Now, this actually makes more sense why when we talk about carbon, we actually have seen that carbon atomic mass is actually 12.001, which means it's more closer to C12 atom. In this part of the video, we are going to find the relative atomic mass of this element, and the formula we are going to use is given here: M1, which is the mass, P1, which is the percentage of bond. So that's for the first isotope, and the second one is for the second isotope. So now we can see for using this graph that we have actually 3 isotopes, and we also have the relative atomic the abundance percentage, and as well as we have the mass number. Now, just by looking at it, okay, which one do you think is the heaviest isotope? Now, these are mass number. So when we look at the mass number, we can say that 26. So this is the heaviest isotope. This is the lightest, and this one is in the middle. So to find this out, what we can do, as I have shown you the example for the school children, we can do is 79% into 29. So this should be percentage plus 10% into 25 plus 11% into 26, and that should give me the relative atomic mass. And if we calculate that comes out to be. So just by calculating that, we can find the atomic mass, or the average atomic mass, which comes out to be 24.32. Now, just by looking at this average atomic mass that we have calculated, we can say that this one is actually close to the first isotope, or we could say the lightest isotope, as it's also visible from this graph where we see that the relative percentage abundance is 79. Now, using the same concept, we can find the average atomic mass of any element. Let's even make some elements up. Okay, let's call this X. So this one X17, and this one X19. So this is the atomic mass of these 3 different isotopes. And now, what you need actually is just the percentage abundance. So maybe the percentage abundance is not given. What's given is into ratio. And what you can do is that convert this ratio into percentage and do the same thing. So it's going to be very easy as long as you know the average atomic mass, the atomic mass of these isotopes, and you know the percentage abundance of it. You can always find the average atomic mass. Thank you for watching.